Since we are looking at food in various ways as it relates to environmental impacts and carbon footprint, let's add a little bit more here in terms of a concept of opportunity cost. I think most of you may know what an opportunity cost is. When you do something, you are obviously maybe choosing that over something else. So comparing the costs, benefits, enjoyment, kick you will get out of that, the investment payoffs, whatever is called an opportunity cost. So in the case of food, we can say the opportunity cost of shifting from a meat diet to a vegetarian diet is that you reduce the land use. That land would then be, let's say, grown into a forest, grassland, savanna, wildlife, all sorts of things, which has basically additional benefits of changing the land use because of your diet shift. Okay, so that's an opportunity cost of our food consumption. So it's a good concept, and let's see how it works. We have already seen this before, where we looked at the carbon footprint of protein-rich foods. So we are looking here at the carbon footprint. Obviously, beef, the diet sector, the dairy sector provides half of the world's beef. This beef creates 60% lower emissions than dedicated beef herds. And here we are looking at producing 100 grams of protein from beef emits 25 kilograms of CO2 equivalent on average, but this ranges from 9 kilograms to 105 kilograms, so that's from 10th to 90th percentile range. So we already saw that the beef produced in different countries have different carbon footprints because of these sorts of ideas. You also have similar range for a lamb. Average emission is at about 20 kilograms CO2 equivalent. Farmed shrimp we looked at, cheese, pork, chicken, eggs, farmed fish, tofu, beans, peas, nuts. Nuts can even have negative carbon footprint here. So this is greenhouse gas emissions per 100 grams of protein in grams of carbon equivalent. So many nut products are carbon negative even after accounting for other emissions and transport. This is because today tree nuts are expanding onto cropland and removing CO2 from the air. So you can see the benefit there of how nuts are grown on trees, and that results in additional carbon. So this is relative change, so you have to be careful. They are not net negative, they are just net negative with respect to what they are replacing, which is what we mean by opportunity cost, right? So if you shift from high meat diet towards more vegetarian diet, even forgetting your proteins, so protein-rich foods are what we're talking about, you can see that some of all protein-rich foods can be lower on this range here. So 7% of protein production creates between 3 and 11 kilograms of CO2 per 100 grams of protein in this range. 25% of production between 11 and 250 kilograms CO2 equivalent generates 70% emissions from protein in total. This is equivalent to 5 billion tons of CO2 equivalent. This is more than the EU total emissions. Okay, many ways to look at it, but the basic idea was that any reduction in meat consumption is going to be good for the environment. Of course, we have always said that there are cultural practices, there are preferences, there are sometimes options that are not available for these kind of protein-rich diets and so on and so forth. So Remembering that, then how much could we reduce annual global emissions through dietary change? So now we are looking at reductions relative to the change. So shown is the potential reductions in global greenhouse gases if everyone in the world would adapt a given diet. This is measured relative to current emissions from food. So you're taking average emissions now. It includes annual emissions from food production plus potential carbon sequestration in vegetation and soils on spared agricultural land. So we are doing some calculations here where we are saying if people shifted diets, it would reduce land use change for the high environmental footprint food production, and that land then could be used for additional carbon sequestration. So we are looking at production emissions, annual emissions reported from life cycle analysis, and opportunity costs of land, the potential of carbon sequestration from regrowing vegetation on land currently used for agriculture. So global average diet today, global food production emits 13.7 billion tons of CO2 equivalent each year, equal to 1/4, 26% of total emissions. We've already seen this in many ways. This does not include potential carbon sequestration, of course. So no beef, no lamb. You would save some from production cost and 80% from the opportunity cost. So total of 7.1. So this is the opportunity cost in green. Total reduction of 7.1 gigaton CO2 equivalent per year. No beef, no lamb, no dairy. You would move that to 12.3 gigaton CO2 per year opportunity cost recovery. No meat or dairy except egg and fish would take you to minus 13.6 gigaton CO2 equivalent per year. And being totally vegan and skipping all these things would reduce your opportunity cost, or what we do, what would cost if you were not a vegan. I don't know, however you want to think about it. Total savings would be 14.7 gigaton CO2 per year. So this is obviously carbon dioxide equivalence we measure using global warming potential, as we talked about, and there are details there as well, whether you do it per kilogram or per molecule and so on and so forth. Global land use for agriculture across different diets. Global agricultural land use is given for cropland and pasture for grazing livestock, assuming everyone in the world adopted a given diet. This is based on reference diets that meet calorie and protein nutritional requirements. So when you expect people to shift, or you suggest people to shift diets, you have to make sure that you are maintaining some nutritional standards as well, and not just saying what is good for the environment. Okay, so cropland, current global diet, 57% used to produce direct human food, 538 million hectares for animal feed, and pasture is 2.89 billion hectares, so total of 4.13 billion hectares here. If we cut out beef or mutton from daily diets, we would save 1.7 and 1.04 billion hectares each. So that would result in a total saving of 2.21 billion hectares from croplands and pastures. If we went to no beef, mutton or dairy, it would result in 1.1 billion hectares, because you would take out the pasture land use completely. No red meat, dairy or poultry would give you 1.01 billion hectares in land use saving. So shifting to a plant-based diet reduces the amount of cropland we need. We can divert land used for animal feed to produce more food for direct consumption, because animal feed per calorie, per kilogram of protein, whatever you want to think about, is very, very expensive. It's a very inefficient way to grow food. If you go completely vegan, you would reduce your land use to 1 billion hectares. So this is the if everyone ate a vegan diet, we would reduce the amount of land we use for agriculture by 75%. This is an area the size of North America plus Brazil. just imagine how much land saving would result, and the opportunity cost in terms of what alternative use that land could be put to sequester more carbon. Another way to look at from Lancet diet, how much carbon dioxide could regrowth of trees and wilderness store if we changed global diets. Using land for agriculture, either crops or pasture for livestock, prevents natural vegetation such as forests or wild grasslands from growing on that land. The CO2 this land could sequester is the carbon opportunity cost. Okay, so that's how it's calculated. Carbon emissions are positive here and it's negative, or carbon is stored over here. And let's note that these figures only include carbon storage in vegetation. It does not include reduction in greenhouse gas emissions from food production itself. Soil carbon sequestration is also not shown, but the authors estimate an additional 135 to 225 gigaton CO2 of carbon storage in soils. So soil carbon, which is severely degraded due to human activities, can be used as a significant source of carbon as well, even though there are articles saying that we are overestimating its overall impact on the total drawdown. Nonetheless, here we are talking about billion tons of CO2 with business as usual scenario, going from pasture land and cropland again. So if we eat the Lancet diet with less meat and dairy, not zero meat and dairy. So that gives you room for compromise. So pasture land and cropland together would sequester 332 gigaton CO2. If everyone adopted a vegan diet by 2050, we could sequester 547 gigaton CO2 in vegetation, for example, forests, wild grasslands restored on abandoned farmland here. This is equal to 15 years. There's a chopper going by, so I don't know if I want to keep screaming or stop for a second. Go away. Okay, so this is equal to 15 years of current emissions from fossil fuels. 15 years of emissions could be put away. 72% from abandoned pasture, 28% from cropland used to grow animal feed. So if you look at the carbon footprints over the Holocene put together, let's say by Bill Rediman, you will see times when people, humans, moved around, converted forests to agricultural land, and then abandoned it for whatever reason. And there are examples where such recoveries happened. So one has to look at those abandoned lands, agricultural lands, and carbon sequestration, additional carbon sequestration from the past as well. If we go for a complete vegan diet again, this is the savings in pasture and cropland, so a total sequestration of 547 gigaton CO2, as we already said. Okay, how much carbon would we sequester with dietary change? Looking again, we already said this, so let's just repeat. 547 gigaton CO2 if everyone switched to a vegan diet. We could sequester this by 2050, in case I didn't say that clearly. Lancet diet would give us 332 gigaton CO2 by 2050. And comparing that to carbon budget left from 2020 to 1.5 degrees C, 1.75 or 2 degrees C, you can see there is 33% chance, in this case 67% chance. So obviously if you reduce the probability with which you are going to hit the global warming target, then you are going to obviously increase the room for emitting more carbon, but that's not the point. Okay, so carbon budget left calculations always make me a little bit nervous because of the uncertainties involved in those projections and so on. Nonetheless, you can see that these are significant fractions of the targets we are aiming for by 2050. Okay, Years of fossil fuel emissions in 2019, 36 gigaton, 1 year, 5 years, 10 years. So that's in terms of gigatons CO2 emissions. So basically we take current emission rates and try to see how many more years of these emission rates can go on with projections of how we will increase the emissions again. Just look at these numbers so that you get a sense of how much opportunity cost there is in dietary change and alternative use of those lands. But these numbers in terms of carbon budget left and years left, always remember that there are certain uncertainties there that we should be mindful of, especially in using those as a narrative where we say we have only 7 years left to save ourselves and so on, which I'm not a fan of. Okay.